Hello friends, welcome to my channel The Lost Page of Physics. Here we basically discuss physics topics and multiple choice questions for competitive students, particularly for those who are willing to take admission in various courses like graduation, masters and beyond. Topic 1, Lecture 3, Linear Algebra Matrix, and next few lecture will be on this topic. Today we will discuss solution of the problem given in last lecture, cofactor of a matrix element and cofactor matrix, adjoint of a matrix, properties of adjoint of a matrix, inverse of a matrix and properties of inverse of a matrix, and at the end of this lecture I will give you two interesting problems. Problem 2, which is given in previous lecture, the trace of a real 4x4 matrix U equal to exponential A, where A equal to 0 0 0 pi by 4 0 0 minus pi by 4 0 0 pi by 4 0 0 minus pi by 4 0 0 0 is option A 2 root 2, option B pi by 4, option C 0, option D 2. Given matrix A equal to this, so A square equal to minus pi square by 16 I, where I is the identity matrix of order 4. So A cube will be A square into A equal to minus pi square by 16 I into A equal to minus pi square by 16 into A. Similarly, A to the power 4 equal to A square into A square, which will be minus pi square by 16 I into minus pi square by 16 I equal to pi to the power 4 by 256 I, and so on. Now we know that exponential x equal to 1 plus x square by factorial 2 plus x cube by factorial 3 plus dot dot dot. So exponential a equal to I plus a square by factorial 2 plus a cube by factorial 3 plus dot dot dot. So trace of exponential a will be trace of I plus trace of a plus trace of a square by factorial 2 plus trace of a cube by factorial 3 plus trace of a to the power 4 by factorial 4. Now we have to put the values of a square, a cube, a to the power 4. So trace of exponential a will be trace of I plus trace of a plus trace of minus 1 by factorial 2 pi square by 16 I plus trace of minus 1 by factorial 3 pi square by 16 a plus trace of 1 by factorial 4 pi to the power 4 by 256 I, or trace of exponential a will be trace of I plus trace of a minus 1 by factorial 2 pi square by 16 trace of I minus 1 by factorial 3 pi square by 16 trace of a plus 1 by factorial 4 pi to the power 4 by 256 trace of I. Since we know that trace of CA equal to C into trace of A, where C is a constant. Now since trace of I equal to 4 and trace of A equal to 0, so trace of exponential A will be 4 plus 0 minus 1 by factorial 2 into pi square by 16 into 4 minus 1 by factorial 3 into pi square by 16 into 0 plus 1 by factorial 4 into pi to the power 4 by 256 into 4 plus dot dot dot, or trace of exponential a will be 4 into 1 minus 1 by factorial 2 into pi square by 16 plus 1 by factorial 4 into pi to the power 4 by 256 plus dot dot dot. Since this is a cosine series, so this will be 4 into cos pi by 4 equal to 2 root 2. So correct option will be A. Now let me start with cofactor of a matrix element and cofactor matrix. A determinant of order n is a scalar associated with an n cross n matrix A equal to Aij, which is written as D equal to determinant of A equal to A11, A12, a1n, a21, a22 a2n, an1, an2 ann, and is defined for n equal to 1 by d equal to a11. So for first order there is only one element a11. So here d equal to a11 and is defined for n greater equal to 2 by d equal to ai1 ci1 plus ai2 ci2 plus ain cin, where I equal to 1 2 3 n, where Cij equal to minus 1 to the power I plus j Mij, and Mij is a determinant of order n minus 1, that is the determinant of the submatrix of A obtained from A by deleting the row and column of the entry Aij, and Mij is called the minor of Aij in determinant D, and Cij is the cofactor of Aij in determinant D. Let me give an example. Let A equal to A11, A12, A21, A22. Then cofactor of the matrix A is Aij equal to A22 minus A21 minus A12, A11. Adjoint of a matrix. Adjoint of a matrix is defined as the transpose of cofactor matrix. If A equal to this matrix, then adjoint of A equal to cofactor matrix transpose. That means we have to form a cofactor matrix by taking cofactors of each element, and then we have to transpose it. Now, properties of adjoint of a matrix. First property, adjoint of A into A equal to A into adjoint of A equal to determinant of A into In, where In is the identity matrix of order n. Second property is, if A is a square matrix of order n having determinant m, then determinant of adjoint of A equal to m to the power n minus 1. Now, inverse of a matrix. Let A be a square matrix of order n and B be a square matrix of order n such that AB equal to BA equal to IN, then B equal to A inverse equal to adjoint of A by determinant of A. Then A is called inversible matrix. Now, if A has inverse, that is determinant of A not equal to 0, then A is called non-singular matrix, and if A has no inverse, that is determinant of A equal to 0, then A is called singular matrix. Now, properties of inverse of a matrix. First property, any inversible matrix possesses an unique inverse. Second property, the necessary and sufficient condition for a square matrix A to possess an inverse is that it is non-singular, that is, determinant of A not equal to 0. Third property, ABC inverse equal to C inverse, B inverse, A inverse. For example, let A equal to 3, 1, 2, 4, and we have to find A inverse. So here is the simple steps. Step 1. To find cofactor of A. Cofactor of A is 4 minus 2 minus 1 3. Step 2. to find adjoint of A, that is transpose of cofactor matrix, and adjoint of A is 4 minus 2 minus 1 3 transpose, that is 4 minus 1 minus 2 3. And step 3 is to find the determinant of A. Here the determinant of A is 10, so A inverse equal to adjoint of A by determinant of A equal to 1 by 10 into 4 minus 1 minus 2 3, that is 0.4 minus 0.1 minus 0.2 0.3. I told you that at the end of this lecture there will be two problems. So here the problems. Problem number 3. If A is a 3 cross 3 matrix with determinant 3, then the determinant of adjoint A inverse is equal to option A 1 by 729, option B 1 by 6561, option C 1 by 81, option D 1 by 243. And problem number 4, if I is an identity matrix of order n cross n and adjoint of 2i equal to 2 to the power k into I, then k is equal to option A 1, option B 2, option C n minus 1, option D n. Solve this problem and write your answer in comment. Solutions are available in next Sunday's lecture.
Never miss a video. Subscribe our channel, The Lost Page of Physics, to get lectures on every Sunday. And press the bell icon to get notification. Thanks for watching.